So if we look at this, we have the superscript 0, which means we're using the standard conditions, and the standard conditions is what is tabulated in this chart. So we grab the chart, we find the entropy values for each reactant and product from the chart. So here we have 219.8, 130.6, and 229.5. Now, those are the numbers on the chart, and it's important to remember that those numbers have units. And the units on this chart are joules per mole Kelvin. So that gives you the idea that entropy is temperature dependent because we're putting in the Kelvin. Now, these are different than the enthalpies because this is joules per mole Kelvin, and the enthalpies were always in kilojoules per mole, remember? So later on, we're going to have to switch joules for entropy into kilojoules when we start combining it with enthalpy values, which we're going to do a little bit later. So now we found the values. Now we use the equation. Delta S0 is the entropy of the products minus the entropy of the reactants. And hopefully you remember from doing this in Chem 111 that if the coefficient in the balanced equation is different than 1, you multiply the number in the chart by that coefficient. Even if it is 1, you multiply it. But when we write 1 mole, it doesn't change the math, right? So the standard entropy change is going to be 1 mole times the entropy for the C2H4. I'm sorry, the C2H6, because I start with the products, the C2H6, minus 1 mole times the entropy for C2H4, because it's products minus reactants, minus 1 mole times the entropy for hydrogen. Now, some of you might like to add up all the numbers on the right and add up all the numbers on the left and just subtract once. That's fine. It's always products minus reactants. I just like to write down the products, add them in, and subtract out the reactants. It doesn't matter how you do it. The biggest mistake I typically see is that I see students somehow slip a sign. Because remember, if you're subtracting a negative number, it goes positive. Or if you get products and reactants mixed up, then you're going to have the wrong sign. So now, my standard entropy change is equal to 1 mole times the entropy for my ethane, 229.5 joules per mole Kelvin. Weird units, but just write them down. Minus 1 mole times the entropy for the C2H4, 219.8 joules per mole Kelvin. Minus 1 mole times the entropy for hydrogen, 130.6 joules per mole Kelvin. So delta S0 is equal to negative 120.9 joules per Kelvin. See the strange units? The moles have canceled. We're left with joules per Kelvin. Minus 219.8 joules per Kelvin. Minus 130.6 joules per Kelvin. So delta S0 is equal to negative 120.9 joules per Kelvin. Now, this is the standard entropy change. We are at 298 Kelvin and 1 atmosphere pressure. What?
How is this 120?
I have no idea.
It's supposed to be the 229.
This is 229.5. Okay, and it was a positive 229.5. Right. Minus and minus, and the answer is negative 120.9. Yeah, sorry, I was talking and my eyes moved down one line. I grabbed the wrong number when I started. Okay, so now when you look at this and we look back to the top of the page at the chemistry, would it be appropriate to use the subscript F here? Is this reaction that I just calculated, is this a formation reaction? Does it meet those criteria? Because why? Because I'm making 1 mole of product. Does it meet the other criteria? No. All of my reactants are not elements in their natural states, are they? No. So yes, I am forming 1 mole of material, but since I'm not using elements in their natural states, this does not count as a formation reaction, so we don't use the F. Okay, here's one for you to try. Go ahead, use that chart and do this one with your groups on your boards.